Alright guys, welcome back. We have another question from the first chapter of the engineering mechanics, and we have this 500 weight that is supported by two cables, the cable forces being F1 and F2, and we know that the resultant of the F1 and F2 is a force of a magnitude 500 newtons acting in the y direction, and the question is asking us to find the F1 and F2. So what we know is that the resultant of these two forces is going to be along y direction, so it's going to be our F, which we know is 500 newtons. And later on in the engineering mechanic, we're gonna get familiar with the concept of the equilibrium, which means the sum of all forces has to be zero in x and y direction. But basically what the question is giving us is that the resultant F is along y direction, which means there is no x component for F. You know, our F would be sum of all forces in x direction, if you just want to show it in a vector form, plus sum of all forces in y direction, J. We can call this one also fx and fy. So from the question, we know the I component of the force F has to be 0. So, and this is going to be our positive direction for x. So we have the x component of the F2, which is F2 cosine of 50 degrees, and it will be positive since it's to the right. So this will be the x component of F2, and this will be our y component of F2, F2, y. And we're going to have similar story for F1 cosine of 35, or we can call it F1x, and this will be F1y. So as we can see, the x component of F1 is to the left, so negative F1 cosine of 35 degrees equals 0, and from here we can find the relationship between F1 and F2. So basically F1 is F2 times cosine of 50 degrees over cosine of. So that's one equation, and second equation is our sum of all forces in x and y equals 0, and this is our positive direction for y. So we can see both of them are actually positive since they're upward. So F2 sine of 50 degrees plus F1 sine of 35 degrees equal to 500. And from here we just need to plug in our F1 into the new equation. So F2 sine of 50 degrees plus, instead of F1, we're going to put F2 cosine of 50 over cosine of 35 degrees times sine of 35 equal 500, and we can just factor F2 in here. So sine of 50 plus cosine of 50, this is going to be here 2 divided by cosine of 35 degrees, and this will be equal to 500. And we can just put, instead of that, tangent of 35 degrees. So our F2 would be basically 500 divided by sine of 50 plus cosine of 50 times tangent of 35. So our F2 will be 411.14 newtons. And if we just plug the F2 in here, we can find F1. So this value times cosine of 50 divided by cosine of. So the F1 would be 22.62 newtons, and that's going to be the final answer for this question. We figure out the F1 and F2, and yeah, that's about it for this one. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.